The video segment for homework number 3. It is not your imagination. Actually, this homework number 3 is pretty much identical to homework number 2 as far as the format. Of course, I have selected different set of problems, but these two homeworks are so important that I decided to basically duplicate them. All right. Now, the first problem is given here. It says that suppose this parameter t is pi over 4 like that. Why don't you find the basically sine and cosine of and the coordinates of these different points? Okay. All right. So before I do this problem, I want to emphasize you that there is quite a bit of elements of memorizing involved in these problems. Let me remind you what is it that you have to memorize, and there is no ifs and buts. You really have to do it. So because calculator will carry only so far. So here's a trig circle. The angles that are important for us are the reference numbers or reference number angles. So this is these are the t values. T is 0 here, and there is pi over 6. There is t equal to pi over 4. There is t equal to pi over 3. And here is t equal to pi over 2. Obviously, this is t equal to 0. So let me write the coordinates here. For example, the coordinates of this point, I'll write it like that. This is x, and there is y. And I want to remind you that this is the cosine axis, and this is the sine axis. Okay? So here, obviously, x is 1, y is 0. Here, x is root 3 over 2, and y is 1/2. Over there, x is root 2 over 2, root 2 over 2. For pi over 3, it is 1/2, x is 1/2, y is root 3 over 2. And obviously, at this last point, x is 0, y is 1. So what is the meaning of these things that I wrote down, for example? So what it means is that if you look at t values, 0, pi over 6, pi over 4, pi over 3, and pi over 4, pi over 2, right here, pi over 2. These are the x values, which are cosine of t, and these are the y values, which are sine of t. And for example, when t is 0, this is 1, this is 0. When t is pi over 6, this is root 3 over 2, y is 1/2, root 2 over 2, root 2 over 2, 1/2, root 3 over 2, and here pi over 2, x is 0, cosine of pi over 2 is 0, and y is 1. So this table, as a part of your education in this course, you really have to memorize one way or another. Okay? There's no way that you can do a calculus not a calculus, trigonometry class without actually knowing these. All right? Okay, so now that we know these, and incidentally, the reference number for these, because these are all less than pi over 2, positive less than pi over 2, these are the same as the reference number. The reference numbers are the same. Pi over 6, pi over 4, pi over 3, and pi over 2. Okay, this is why I don't have to refer to as reference number anymore because these are the same. So let me close this, save that, and let's go and do this problem right here. So what I've done is actually prepare the, just like the other assignment, I've prepared the PowerPoint slide here. So first of all, when t is equal to pi over 4, the reference angle is the same. This is the, let me see now. Okay, the reference angle is right here, the same thing as the angle itself, or the reference number is the same thing as the number itself. And notice that this value and 3 pi over 4 over here, this is 3 pi over 4, this is 3 pi over 4, the blue arc is corresponding to 3 pi over 4. It has a reference number the same as pi over 4, and they have the same height, which means the same sine. See, they're the same, and the cosine are numerically the same, except that the signs are different. Okay. When we go to the next one, is this when you go to the next one, okay, right there. So we are dealing with let me see again. We are dealing with the t value being pi over 2. Therefore, the reference number is the same. Obviously, cosine, which is the x, is 0, and sine, which is the height, is 1. And when you compare this with 3 pi over 2 down here, okay, the reference number for 3 pi over 2 is the same as pi over 2. Therefore, for example, just look at the drawing here. The cosine is the x value, which is 0, same as that. And the sine is 1, except that it is minus 1 because one is above the axis, the other one is below the axis. So down here, this angle 3 pi over 4 is right there, and I compare it with this guy, which is 5 over 4 down here. Both of these have the same reference number, pi over 4, and what that means is that if you know the stuff about pi over 4, we can write the things about 3 pi over 4 and 5 pi over 4, except that you have to watch out for the sign. So this for example, notice that we already did this point in the first transparency, okay, the first slide. So they have the same 3 pi over 4 and 5 pi over 4 have the same x. That's why these are both negative root 2 over 2. And the y's are almost the same, numerically they're the same, but one is positive, the other one is negative. This thing is what was done in the first slide, okay? All right, these 2 points, obviously, for t equal to 0, the cosine is 1. You can see that, cosine is 1. Cosine is 1, sine is the height y, which is 0. And on this side, cosine is minus 1. See that? This numerically, this is the same as, numerically, this is the same. I don't know what's happening here. This value and that value numerically are the same, except that one is positive, the other one is negative. This is positive, the other is negative. And finally, the last one. Okay, the last one here, you can see that the cosine is the same. Just look, cosine is this. Both of them same number, positive, but the sign of them, sign meaning S-I-N of them, numerically the same, but one is positive, one is negative. Okay, that kind of wraps up this particular problem. Now let's go to the other ones. Okay, so concentrate on 5. Okay, so let's concentrate on this number 5. This one. Where is 2 pi over 3? We are looking at the t-value 2 pi over 3. I do not, on purpose, do not want to talk about angle here. We're just talking about going around the unit circle at a certain length, and the length is 2 pi over 3. Okay. Yes, it is true that these will become angle of something later on, but we'll worry about it later. Okay, where is 2 pi over 3? Now remember, pi over 3 was right there. 2 pi over 3 will put you over here, there. Remember, this is x, and there is y. This is sine of t, and this is cosine of t. Okay? So you notice that the reference of this, the reference number is pi over 3. So t bar is pi over 3. So I'm struggling with the stuff about pi over 3. I just have to worry about the sign. So this number is, here's pi over 3. You can see that pi over 3 is over here, right there. Okay, they have the same SIN, so you have to know SIN of pi over 3, and that was root 3 over 2. So this is also root 3 over 2. Look, this height is the same as that height, and this was pi over 3, the height of pi over 3, which is root 3 over 2. It was root 3 over 2. Okay? With a cosine, on the other hand, they're off by a negative sign. Now, cosine of pi over 3 was 1/2. This was pi over 3, right? Reference number. Okay? And the cosine of it, they're numerically the same, but one is negative of the other one. So this is minus 1/2. Obviously, tangent is the ratio of these two, which is going to be root 3 over 2 divided by 1/2, and that is root 3. So we have answered everything that we need to know about 5. Okay, let's erase this stuff. We need these. I'm going to redraw my unit circle. Okay, let's do it. Okay, so let's see now. We're interested in 5 pi over 3. So where is 5 pi over 3? Remember, 5 pi over 3, you can look at it as, for example, 2 pi minus pi over 3. So when you look at the unit circle, like this is cosine, this is sine. You go 2 pi counterclockwise, you end up right here, and you back up by pi over 3. So you go one round and then back up, go backwards. Okay, so there it is. This is the point that we're interested in. Now notice that the reference number for this is pi over 3. This is the reference number. So if you know everything about pi over 3, and you do, you know its sine, you know its cosine, then you can write the answer to the question that we have with the appropriate signs. So look, cosine of this is the same as cosine of pi over 3, and the numerical sign, SIN, is the same. So this is 1/2, because cosine of pi over 3 is 1/2, and therefore cosine of 5 pi over 3 is also 1/2. This is pi over 3. Okay? Now, cosine of minus 5 pi over 3, let me remind you that the easiest way of doing this is to say that, wait a minute, cosine is an even function. So cosine of minus a number is the same as cosine of the number itself. We talked about even and odd functions. Therefore, based on that, you can say, ah, wait a minute, this is 1/2, because cosine of 5 pi over 3 was 1/2. It's a fast way of doing it. Now, this is cosine of 7 pi over 3. So let me erase all this stuff, because we're now interested in 7 pi over 3. So let me erase this. I'm going to redraw the unit circle. Okay, there's the unit circle. There is the unit circle. I don't want the eraser. There. Okay, now we can draw the unit circle. There's the unit circle. And there we are interested in 7 pi over 3. 7 pi over 3, remember you can write it as 2 pi plus pi over 3. So the place that we end up with terminal point, you go all the way around 2 pi, and on top of that you go another pi over 3 up. So this is 7 pi over 3. And let me remind you that this thing is, this thing, which is the reference number, is pi over 3. So actually, the sine and cosine of this 7 pi over 3 are identical to the sine and cosine of pi over 3. So this thing is the same as cosine of pi over 3, and this is 1/2. All these three came out to be pi 1/2. Okay? All right, let's go to this other guy, cotangent, and next row. So let's erase this. I'm going to erase all of these. Okay. All right. Okay. So let me draw the unit circle for you, right there. We are interested in, this is 18 we're doing 18, okay? Minus pi over 3. Where does minus pi over 3 lie? So this is, first of all, this is cosine, this is sine. Minus pi over 3 is right here. You back up by pi over 3, okay? Now, remember, this is the reference number. So anything that we can say about this, this is cotangent right now. If you know the stuff about pi over 3, we can write this. So cotangent of minus pi over 3 is equal to cosine of minus pi over 3 divided by sine of minus pi over 3. And let us use what we already know. Cosine is an even function. So this is the same as cosine of pi over 3. And this is the same as, this sine is an odd function. You take the minus out, minus sine of pi over 3. We already know that this thing is 1/2. And there's a minus sign down here. And this is root 3 over 2. So this is minus 1 over root 3. Okay? Another way to say that is cotangent is an odd function. Cotangent is an odd function. So this is minus cotangent of pi over 3 and cotangent of pi over 3. And therefore, you just follow exactly the same thing. All right. 2 pi over 3. Let's do the part B. Part B. So let me get rid of all of this. Get rid of this. Okay, so here is the trig function. We are interested in cotangent of 2 pi over 3. But the meaning of that is cosine of 2 pi over 3 over sine of 2 pi over 3. Okay? Now, 2 pi over 3 is going to land you right here. Kind of right there. And the reference number for it is pi over 3. Because look, the shortest distance is pi over 3. So the reference number for it is pi over 3. And what that means is that cosine of 2 pi over 3 is negative of cosine of pi over 3. Because notice that the cosine of 2 pi over 3, this is the x length, is the same as this, except that it is negative of that. And sine of it is, of course, is going to be the same value. So this is the same as sine of pi over 3. And since you know everything about these guys, this is going to be minus 1/2 over root 3 over 2, and this is minus 1 over root 3. Minus 1 over root 3. The other one was plus 1 over root 3. The first one, this one was plus 1 over root 3. Let's do the next one. All right. Okay. So my trick circle is becoming worse and worse. Okay, right there. This is cosine. This is sine. This is x. And this is y. Okay. So we are looking at this problem. 5 pi over 3. Okay. Look at it like this. Cotangent of 5 pi over 3 is the same as cosine of 5 pi over 3 divided by sine of 5 pi over 3. And we want to know each one of these. So the way to know each one of these is, the easiest way is to write 5 pi over 3 is the same as 2 pi minus pi over 3. Okay? So where is my angle? My angle is you go around 2 pi and then you back up. You end up with this location. You go around and you back up by pi over 3. So this backup distance is pi over 3, which means that if we know the stuff about pi over 3 down here, this is pi over 3, we can write our answer. So for example, the cosine of this is the same as cosine of pi over 3. It's the same as cosine of pi over 3, which incidentally, we know what it is. It is 1/2. And the sine of 5 pi over 3 is the same as negative sine of pi over 3. And this one is root 3 over 2. Notice that there's a minus sign here, okay? So the net answer, the final answer, is minus 1 over root 3, which I believe was the same as the other ones. I can't remember, I erased them, but anyway, this is the answer to the cotangent of 5 pi over 3. Let's do the last one. Okay, almost there. Okay. All right. There we are. This is cosine. Okay. So we have, let's do this one. Minus pi over 4. Minus pi over 4 will put you down here. Back, go in the clockwise direction by pi over 4. Okay. Now, notice that the reference number for this is pi over 4. That means that if you know everything about pi over 4, and you should have memorized it, you know the answer. So notice that cosine of minus pi over 4 is the same as cosine of pi over 4, and this is root 2 over 2. Another way to say this right away is cosine is an odd function. So cosine of minus pi over 4 is the same as cosine of pi over 4, and that you should have memorized. Okay, let's do another one. Okay, let's do this one. Cosecant of minus pi over 4. Cosecant of minus pi over 4, by definition, is 1 over sine of minus pi over 4. Now you can say that, for example, sine is an odd function, so that becomes 1 over minus sine of pi over 4. And this is minus 1 over root 2 or minus root 2 over 2. Minus root 2 over 2. Another way to justify that is, look, sine of minus pi over 4, just look, is this much. Sine of pi over 4, which is the reference number, is that much. They're opposite to each other, and therefore this thing is minus 1 over root 2. Wait a minute. Sorry, this is a mistake here. It's 1 over this. 1 over this. That's bad. So this is equal to minus root 2. The answer is minus root 2. You can say it based on the fact that sine is an odd function, or you can look at trig circle and say that sine of minus pi over 4 is negative of sine of pi over 4. Let's do the last one here. And this is going to be the end of video 1 for homework 3. And then the rest of the homework I'm going to do in a separate video segment. Okay, so let's do it. This is the cosine axis, that is the sine axis. There we are, and we're doing this one. So cotangent of minus pi over 4 is cosine of minus pi over 4 divided by sine of minus pi over 4. Let's use our knowledge. Instead of going to the trig circle, let's use our knowledge that cosine is an even function, sine is an odd function. So that means the top is cosine of pi over 4. The bottom is minus sine of pi over 4. And this means it's root 2 over 2 over minus root 2 over 2. And this is minus 1. Minus 1. So what I'm trying to say is that some of these problems, you can do it right away by looking at the fact that sine is an odd function, cosine is an even function, or you can go on the trig circle and look at the reference number. The outcome is the same. Because if I did not rely on the fact that sine is odd, cosine is even, then I would have to find what the reference number is, and I have to have memorized all the reference numbers, and this is how we do the problem. Okay, so I'm going to stop here, and then we go to the other video segment in a minute.